All right, hi guys, here's the practice problems for chapter 8. I'm going to take problems 3 and 4 out of the book, but I'm going to make a few changes to them. We talked about in our lecture the factor rating, wherein we take a series of various factors that we care about when we are determining where we're going to build our new facility space. So the example from the PowerPoint was proximity to existing source, traffic volume, rental cost, size, layout, operating cost. And then we collectively, as managers, determine how important each of those factors are to us. So 10% of our decision should be based on its proximity. 40% should be based on the rental cost of the new facility. 20% should be based on the layout of the facility, right? And all those weights should add to 1. And then, of course, after telling us that all the weights typically sum to 1, meaning they're done as percentages, they give us a practice problem in the book that doesn't give percentages. It gives in the book, this says 5, 3, and 2. I've changed it to 0.5, 0.3, and 0.2 just to keep it clear and consistent with what you've learned in the PowerPoint and the problem you'll be doing from your problem set this week. So I have changed it a little bit there. But the idea then is once you have done that, you then go to both of the site locations and give a subjective score of anywhere from 0 to 100 for each of those factors. Okay, we've gone to here and we're scoring this a 100 out of 100 on proximity to our existing source. We're giving this location a 60 out of 100. Rental costs, the higher score would be typically better, meaning the costs are actually lower, but the score is good if the costs are low. That's how they would do it in this example and so on. So we've scored all of them, and then we just multiply the weight times each factor's score and then sum those products together. So yes, we'll be using an equal sum product function this week in Excel. Doing it by hand, not terribly challenging, though, fortunately. So determine which location, so between A and B, which location has the higher factor rating given the following information. So again, I've changed the 5, 3, and 2 to a 0.5, 0.3, and 0.2, and you'll see that adds up to 100% or 1.0. 50%, 30%, 20%. That's the same thing as 0.5, 0.3, 0.2. All right. So labor costs, material costs, and transportation costs, those are the 3 factors in our practice problem. And we've gone to the location, and the labor is going to be pretty, labor cost score is pretty good. So not the cost, but the cost score is pretty good at B, not as good as A, not as good at A. Material cost also better at B. Transportation costs, though, much better at location A. However, if we're looking at it, we care way more about the labor cost than we do the transportation cost. 50% of our total score is going to be based on the labor cost score. So my prediction is that B is going to come out ahead by virtue of it being higher on the one we care about more, but let's find out. So let's say I was doing this by hand for the quiz purpose. Again, doing it by hand and punching in the answer will not get you anywhere on the problem sets. Those have to be solved by showing your work through Excel formulas and functions. Reiterating that on this video. But if I was solving this by hand for a quiz purpose, I would do 50% times 20 plus 30% times 10 plus 20% times 50. It's the same formula you've used for weighted average in several chapters already at this point. Chapter 3, weighted moving average formula. It's the same formula, different ways of thinking about it and saying it, but it's a weighted average. So 0.5 times 20, I'd start by doing that. Well, 0.5 is 50%, half of 20 is 10, but 0.5 times 20, 10. So I just write down 10. 0.3 times 10, right? 0.3 times 10, 3. And then 0.2 times 50, okay? I get 10. Once I get all of those, I then add them all together. So I'm going to sum the products, 10 plus 3 plus 10. And this location would have a factor score, weighted score of 23. So location A gets 23 points. Location B gets 0.5 times 40 is 20. 0.3 times 30 is 9. It's weird. I wonder why those are showing up blue all of a sudden. 0.2 times 10 is 2. I don't like that one bit. All right. And then after that, I sum the products. 20 plus 9 plus 2 is 31. So that's how I would solve that if I was doing it by hand and just writing it down as I was going for quiz purposes, right? And then location B has the higher score, so location B wins. If I'm doing it on Excel, two choices, both acceptable. One would be to do equals this times this, plus this times this, plus this times this. So basically recreate what we've done on pen and paper. But we could also do an equals sum product function. So sum product, choose our first array. And now because we want to copy this formula down from location A to location B, I would want to lock in the weight. So I always want it to be referring to those same weight inputs. So I will lock that in by pushing F4, which adds, you can see all the dollar signs between the letters and numbers to lock in everything from F14 down to F16. That's my first array. My second array are the scores from location A. Hit enter and I get 23. Now copy that over one spot and I get 31. That's all there is to the factor rating part of your problem set this week. Just make sure that you are showing your work either with the sum product function or this times this plus this times this plus this times this, all in here as a formula. All right, on to the next problem. This is the center of gravity method. We're going to look at the problem given to us in the book, which was written in this way. Which gave us some quantities being shipped to each of these 4 destinations. But let's look at it both ways, both with or without a weekly quantity. So if I'm locating my facility, this goes back to the visual we saw on our slideshow here. Basically, these destinations refer to a spot on a map, like an XY coordinates, right? So here we have our destinations all laid out on an actual map. Then I'm going to overlay or add a coordinate system to them. So start at the very bottom left at 0, 0. This is your X coordinate. This is your Y coordinate. And then this is at 2, 2. This is at 3, 5, and so on, right? So once you've applied all of those, I then average out all of the X's, average out all the Y's, and the average of each of those becomes my XY coordinates for where I should build my new facility. So for Excel, very easy, equals average of these 4 numbers, and then copy it over. I'd be done with that problem right there if I had that on a problem set. So very easy to do. I should locate my facility at 3.75 on the X coordinate and 6.25 on the Y coordinate. That'd be done, right? Doing it by hand, you're going to want to do 3 plus 6 plus 2 plus 4, and then divide by 4. You're dividing by 4 because there's 4 destination inputs. You're averaging out those numbers still. 3 plus 6 plus 2 plus 4 equals 15. Divided by 4 is 3.75. Okay. Now you can write down your X coordinate. 5 plus 8 plus 7 plus 5 is 25. Divided by 4. Again, there's 4 inputs. 6.25. So very easy to average out. This is a simple average. This is not any kind of weighted average of any kind. And that's your answer if there were no quantities involved. However, if you look at it with quantities being shipped to each location and the quantities differ between locations, well, then some locations simply matter more. You're serving those locations more. And so the cost associated with shipping that many units, you need to be cheaper by having your location be slightly closer to the ones in which you ship more product to. That will end up mattering to your overall transportation costs. So we can apply a weight to this in the same manner that we applied a weight on our factor analysis, just that it's not going to be percentages, but the process is once again the same. This is a sum product feature on Excel. I'm going to take 3 times 20 plus 6 times 10 plus 2 times 15 plus 4 times 15, except I'm not going to be I'm not going to be, if I'm doing it by hand, I'm not going to be averaging them out based on dividing by, it's not going to be just a sum product and leave it at that. Okay. I then have to divide it by, so I can take a sum product, right? But there's one extra step in that I now have to divide it by the sum of my quantities. Okay. If I was to take a sum product of all this, right? Sum product of this and this, you'd see a very high number. Okay. 210, a high number, which should be your clue at that point. I'm probably not going to put my x coordinate at 210 when my other locations are at 3, 6, 2, and 4. It's going to be somewhere in this range, not higher than 6 and not lower than 2. Okay. So if you start thinking, oh, it was a sum product, and then you get a number like that, oh wait, there was another step. That should be your clue that there's one other step, which is you need to divide it by the quantity. So basically we are averaging all of these out as if these were a weight to them. So to do that, we need to take the sum of our weekly quantities, which if we're doing this by hand, we could do by just adding them together and then writing it down. Okay, so 20 plus 10 plus 15 plus 15 is 60. So whatever we get for our sum product, we then need to divide by 60. And that's how we're going to figure out our x coordinate. So basically we're applying a weight to the quantity, and then we're dividing by the total quantity to figure out what percentage is what. There's a roundabout way. I don't want to confuse anyone, but basically we could turn these quantities into a percentage of their own. So we could say, you know, in a cell here, I could do this divided by the sum of this divided by the sum of this, and so on, and get a percentage, and then do a sum product of that percentage. So there is a way to do it. Equals this divided by the sum of all 4 of these. And then we could do a sum product of all my x coordinates in this. So you could do it without dividing by the sum at the end, basically by doing that ahead of time. Not necessary for this problem. Just, you know, for those of you out there who are mathy and like to do the math of it, you can do it that way. But let's just instead figure out the sum of these 4, and we could write that down. Okay. So 60 was the sum. Now, again, let's do it by hand. We got 3 times 20 is 60. 6 times 10 is 60. 2 times 15 is 30. 4 times 15 is 60. Okay. So we're at here. Now we need to sum this number together. Okay. So we've got 60 plus 60 plus 30 plus 60. It's 210. Remember the 210 we got earlier from our sum product function? So we have 210 for this sum. And then, so on the top, we've got the sum of all of our x coordinates times our quantities. And then we're going to divide it by the sum of our quantities. So this is the sum of our x coordinates times quantities. So now we're going to take 210 and divide it by 60. 210 divided by 60 is 3.5. So 3.5 is where we should put our x coordinate for this new location. So you can see a little bit further to the left than the 3.75 from the unweighted one. Now let's do it again for the y coordinates. We're going to have 5 times 20 is 100. 8 times 10 is 80. 7 times 15 is 105. 5 times 15 is 75. Okay. So now we need the sum of all of those. So let's add those together. 100 plus 80 plus 105 plus 75 is 360. We've got 360 for the sum of my products. Now again, the sum of these was 60. So I need to take 360 and divide by 60. And I get 6. So my XY coordinates would be 3.5 and 6 if I'm doing it by hand. But let's do it on Excel as well. So that'd be if you're solving it for a quiz. Take the sum product, the weighted average, and then divide it by the sum of your quantities. Okay, so that's what this is saying. Sum of your quantity, sum of your x times quantity, which is, 360 on the y's, sum of your y times quantities divided by the sum of your quantities, which was 60. 360 divided by 60 was 6. Okay, that part's done. Solve by hand. Let's do it on Excel. Let's do a sum product of my x coordinate, comma, my weekly quantity, lock it in, and then divide that by the sum of my quantities. Lock it in. Hit enter, I get 3.5. So I'll hold that up again for you guys to see. I've got the x coordinates that I'm currently in. All right, so all of those multiplied and then summed against all the weekly quantities. I locked in the weekly quantities because I'm going to shift this x over to the y. So I want the x coordinate here to shift, but I do not want the weekly quantity reference to shift. I divide that sum product by all the quantities added together, the sum of my quantities, and that got me 3.5, just like I did on the long version by hand. Copy it over one time, and I should get 6, and I do. So that's how you would do a weighted average whenever the quantities differ at each location. If they don't differ, like on one of your problems, you just need to average out the numbers. Average the x's, average the y's, and you're done. So honestly, with the sum product feature on your Excel sheet, I mean, you could do this whole problem set, I think, in a couple minutes. Not a terribly challenging one compared to what we've seen in maybe chapter 3, chapter 5. Again, I try to balance out, the difficulty levels in the problem sets to make up for the more challenging ones with some simpler by comparison. Well, not necessarily simple, but simpler by comparison. So also something that's a little easier to do by hand, so that when it comes to the exams, if they've got those all on one exam, that you're not taking up an exorbitant amount of time doing various chapters worth of work. So that's all there is to it for the quantitative practice problems this week. I made a few changes to the book version of the practice problem. The first 2 practice problems in your book have to do with decision analysis. We've covered that completely in chapter 5. There's no need to rehash it here. So thanks guys so much. We'll see you in the next chapter.